In this lecture, we will talk about another kind of objects in Kubernetes known as replica sets. Let's first of all understand why we need replica sets in Kubernetes. When we deploy a pod directly in Kubernetes, as we did in the last lecture by defining the YAML file and applying it to Kubernetes, the pod will be responsible for its health state and its lifecycle. So there is nothing that will continuously check the health state of the pod and make sure that the pod is always up and running. So if the pod fails for any reason, Kubernetes will not be aware of the pod failure and it will not create a new pod, and the users will lose the access to the application running inside this pod. Also, if the traffic increases and you need multiple instances of your application for load balancing and high availability purposes, this is not the right way to achieve that, because Kubernetes will create only one pod when applying the pod manifest file. The solution for all of these problems is to use replica sets. A replica set is a Kubernetes object that we can create in our cluster to deploy multiple instances of the same pod and to make sure that this number of pods is always available. If a pod crashes or fails for any reason, the replica set will notice the pod failure and will create a new pod. It offers also the capability to scale up or down your applications depending on the traffic coming to your applications and depending on your needs. Let's learn now how to create a replica set in Kubernetes. We start first of all by creating the YAML file. We can call it, for example, nginx rs.yaml because we want to create a replica set to deploy some pods running containers based on the nginx image. In the YAML file, we will start with the 4 top-level properties, which are API version, kind, metadata, and spec, as we did with the pod configuration file. For a replica set object, we set the API version to apps/v1 and the kind property to replica set. In the metadata section, we will set the name of the object to nginx rs, and we can associate some labels with the replica set that we may need later for filtering or querying the objects that we have in our Kubernetes cluster. Under the spec section, we tell the replica set about the number of pods that we want to create using the replica property. Here we set the replica property to 3, so 3 pods will be created as part of this replica set. Finally, we have the template property, where we put the pod configuration. We will take the same configuration that we have in the pod YAML file that we have worked with previously, and we will put it here under the template property, but without setting the API version, the kind property, and the pod name. Finally, the last step is to link the replica set to the pods that it has to manage. We do that using the selectors property, where we mention under match labels the same labels that we have assigned to the pod in the metadata section. For this example, the replica set is responsible for managing the pods having the label app nginx. Now the YAML file is ready, and the next step is to apply this YAML file to Kubernetes to create the replica set. And as we did when working with pods, we applied the YAML file using the kubectl apply command, followed by the -f option and the name of the YAML file. After running this command, a message will be displayed on the terminal indicating that the replica set was created successfully. To view the replica set that we have in our Kubernetes cluster, we use the kubectl get_rs command, and here we have only one replica set called nginx rs created 20 seconds ago. Under the desired column, we find the number of pods that must be created as part of this replica set. And the value here is 3 as we set the replica property in the ReplicaSet YAML file. In case we need more instances of our application, for example when the traffic increases, we can scale up the replica set using the kubectl scale ReplicaSet command, followed by the name of the replica set with the -- replica option, which will be set to the desired number of pods. For example, here the replica option is set to 5, so by running this command, 2 additional pods will be created. And we can verify if the replica set was scaled successfully by executing the kubectl getArrest command. And now the desired number of pods is 5, and all of them are up and running. And we can confirm that by listing the pods using the command kubectl getPods. To scale down, we use the same command with the same arguments and option, and we change only the value given to the replica option. For example, if we set the replica option to 2, the replica set will keep only 2 pods up and running, and it will kill the remaining pods. We have mentioned that the main purpose of a replica set is to ensure that a specified number of pods are always up and running. So in case if a pod fails or crashes for any reason, the replica set will notice the pod failure and will create new pod to keep the desired number of pods always up and running. For example, now we have 2 pods up and running as part of the nginx rs replica set. We will delete one of these pods just to simulate a pod failure. And just after a few seconds, the replica set will notice that one of the pods under its control fails, and we create a new pod to keep 2 pods always up and running. Finally, to delete the replica set, we use the kubectl delete command with the -f option followed by the name of the YAML file used to create the replica set. And by deleting the replica set, all the pods under its control will be deleted, and this is the right way to delete the pods created by a replica set. So we delete the pods by deleting the replica set. If we delete the pods without deleting the replica set, the pods will be recreated as long as the replica set still exists in the cluster. So that's all about replica sets in Kubernetes. I hope that everything is clear, and thank you so much.